Okay, so mobile has made a leap every 10 years, starting 1980s. I'm not sure if many of you know, but there was also cellular phones on analog voice only, a long time ago. Now 2G, it's an old technology which is still used in many industrial applications, and operators want to close it because it's costly to maintain, and they need to refresh frequencies for other technologies. So 2G and 3G will be closed in the near future. And for the future, will only remain 4G, and then now the new kid in town 5G. 5G was came as you see it now in 2017, when the release 15, which is the 3GPP standard, was out, and they made some. They split it in two: non-standalone and standalone. I'll share with you later what this means. And then now in 2020, we already have commercial deployments in some areas. In most areas, it's still a lab test, so it's not a public network, but also there is public network in some areas. Next releases or next standard outputs will treat more features related to 5G, more new technologies only related to 5G. Current technologies, current standard, it's also enhancing existing LTE or 4G technology to go along with 5G. Okay, let's see more in detail what is 5G about. So we can split it in three parts. 5G is about unifying diversity. Until now, there are more developments spread on different areas, and 5G wants to unite it all, like cellular and Wi-Fi and all these wireless technologies to be in one point, so they can be transferred from one to another. So first domain would be diverse spectrum. Let's go to the next slide. What means spectrum? Means frequency allocated for radio communication. Until now, what we have for LTE bands, LTE means long-term evolution, if you don't know, we had the so-called sub-6 gigahertz, so frequencies up to 6 gigahertz, usually less than 3 gigahertz. And this has some limits on how much technology can deliver data. So they found out they could use other frequencies for multi-giga BPS data rates. So because they can have larger bandwidths, much more capacity, and lower latency. This lower latency could bring up new opportunities, like remote controlling for robots, for operating on patients, for example. Scalable numerology is referring to the bandwidth in the subcarrier spacing. More exactly, different frequencies allow for different bandwidths, and if this subcarrier spacing is scalable, then you can fit different scenarios, different application scenarios, different frequencies, so they can be compatible. Globally, frequencies shown here were allocated to the 5G spectrum. You see there are different frequencies per country. And the deployment plan in all over the world looks something like this. So sub-6 gigahertz means it's more spread in the world, and millimeter wave, which is over 6 MHz frequencies, are still in test. You will hear about dual connectivity in 5G. This means basically that current LTE network is used because it has a wide coverage. It's everywhere. And 5G is only used to augment applications where really 5G data rates are needed. For example, you don't need 5G to have a normal call wherever you are, but you can switch to 5G service when you need a high data rate or video streaming with high speed, something like this. So 5G actually it's based on LTE. LTE Advanced Pro is, let's say, the threshold between 4G and 5G. So it's still related to LTE to 4G, but has features that are more advanced and not really used by normal mobile subscribers, like gigabyte LTE, LTE IoT, which is evolution from current NB-IoT and Quectel in the next 5G. Cellular V2X, which means technology to communicate from car to car, from car to infrastructure, like car to semaphore, car to buildings, charging stations, or even private LTE networks. So LTE Pro accelerates the expansion of 5G. You see here all these services are based on LTE, which is working now, and only some applications really use the new 5G, the new radio for sub-6 gigahertz, and millimeter wave actually is used to communicate at base level between different data center, different towers. So your normal phone would not have 5 millimeter wave in it. Only towers communicate with this. I told you about NSA versus SA. This means non-standalone. Actually, it's 5G, which depends on 4G. That's why it's called non-standalone. So it's like using satellite communications. First, you have a control channel, like established connection and all what is required on current LTE. And then 5G channel is assigned only for downloading or special services that are capable only through 5G. And standalone means the device and the core, so the operator side, it's all based on 5G. So nothing related to LTE. Next scenario where 5G unifies everything is diverse deployments. There are different type of cells, like small cells, macro cells, device to device, backhauls, like they use to communicate data between towers. Until now, while developing this millimeter wave technology, there was some, let's say, drawbacks, like if you use such high frequencies, the path loss will limit the coverage. And they fixed this by a significant coverage they fixed it with co-seating, which means analog beamforming, narrow beams to overcome path loss. So the signal is streamlined to beams where it's needed, not spread everywhere. So the power is concentrated in more specific areas where the user is located. They said this technology only works in line of sight because it can be blocked by hand, body, foliage, rain, etc. Same technology, beamforming, allows beam tracking to overcome this scenario and fix reflection issues. Only viable for fixed use, like this type of millimeter wave communication is for backhauls and satellites. Now there are some designs for handheld devices that have adaptive beam steering and could also overcome this block and require a form factor. Some people say this would require large antennas because there are issues related to thermal dissipation. But still, we saw innovations like modems with antennas embedded, antennas on more areas on the same phone to dissipate areas that could interfere with the signal, and also for thermal relief. So 5G has this type of antennas, like standard antennas that work on 5G, backhauls that are designed to transmit data between towers, so now directly with the phones, also with the phones, but mainly for high-speed data between the towers. Those are related to fast beam steering and switching. I will share later what this means, what beamforming means. Advantages of beamforming means that they solve transmission fading issues. You don't radiate a signal in all directions, but radiate it on a specified direction. So the gain to the receiver is usable, it's high. It enhances the connection stability and the spectrum efficiency using massive multiple input, multiple output applications. Let's see this more clearly in detail. So this is how 5G beamforming antenna looks like. Actually, it's a spread of multiple smaller antennas, and then each of them are activated, controlled electronically. So it's not just a simple passive antenna, it's a complex electronic antenna. And they activate each of these antennas to form a beam, but in different time slots. So for example, you see here on the right side that it actually beams, so it actually activates these cells from left to right, and then devices which are located, let's say, in the intersection of the beam 1 have a good signal, while other devices located at the intersection of beam 6 or 7 have a good signal, but the same beam doesn't have same signal for both devices. So each device works okay, each UE works okay, but with different beams. So we could say the different antennas, but it's same antenna, just it's using time multiplexing. It's communicating with each device in different timestamps. It doesn't beam at the same time in all directions, because this wouldn't be beamforming, it would be omnidirectional antenna. So it's beaming in one direction at one specific time. Mimo technology means that there are multiple inputs and multiple outputs. You can see here what normal scenario is: single input, single output, so one receiver, one transmitter. And in the picture here, you can see how such a real antenna looks like on the, let's say, BTS side. And also on the mobile phone side, actually there are more such cheap array antennas to overcome hand uh, signal attenuation by hand or other obstacles. Massive MIMO technology basically means there are more such antennas, so up to 64 by 64 or even more, so they can serve multiple devices in the same time. Beamforming has more scenarios depending on application, like to serve a single user by directing the energy towards the user, or to serve still a single user by sending some data in different directions to avoid blocking of the signal, or not sending data to some other user that is served by other cell, or increase data rate by transmitting several data streams, several beams to the same user to have higher throughput, or at high load to serve more users simultaneously with more beams, so to support their need for high throughput. Third department, let's say, third area that is served by 5G is diverse services. So until now, when we talked about cell technology like LTE, 4G, we mainly think about mobile broadband. So 5G, yes, actually means enhanced mobile broadband. So higher speed, transmission speed, higher bandwidth. But this is what you see commercially and what you hear about 5G: faster, higher, better. But there is also two other areas like mission critical control applications. For example, ultra high reliability. So technology to drive the vehicles remotely, for self-driving cars. Ultra low latency. For example, if you want to control robot remotely, you need low latency to react to users' comments. Extreme mobility, like for drones, you need to communicate the drone at high speeds while the drone is moving. And the third area is massive Internet of Things. So what we have now related to NB-IoT and Cat-M, all these applications that came from 2G technology, which are still used in the industry. Now all these massive Internet of Things are a 5G support for this industry, like ultra low energy and ultra low complexity. This is for NB-IoT devices. Deep coverage also. Ultra high density, like many devices per same cell, so in urban areas. Let's see more in detail how this IoT, so current technology for IoT, will evolve in 5G. So from 2G, GPRS evolved in LTE IoT by using NB-IoT, for example. And now all this will evolve in 5G in what is called the in-band new radio. For example, in 5G, we have four, let's say, different technologies. eMBB means enhanced mobile broadband, refers to high speed rates, high bandwidth for video streaming. URLLC means ultra reliable low latency communications for controlling remotely vehicles or robots. C2VX relates to communication between vehicles and infrastructure and buildings, charging stations, semaphores. And this in-band 5G new radio actually includes current LTE IoT. So all what that was defined in release 13, so EMTC or CATM and NB-IoT, we migrate now here. And let me explain how. So this is the spectrum, for example, for 5G. And on the horizontal, you can see, for example, ENBB part. This means this full blue area means that the full bandwidth is used for high-speed data transfer, where you need a large amount of data to be transferred. If you don't need this, so you need a smaller data set, smaller amount of data, but you need to send it more often, then you could split this bandwidth in more. So in the same time, in the same frame, you could send more data, more different data. You will see here your LCC, where you can send synchronization signals to control robots and stuff like this in real time. And similarly, you can allocate bandwidth for EMTC or CAT-M or NB-IoT in the same spectrum. So this basically means that for a current NB-IoT device, which is connected to the network, the device doesn't know it works in a 5G environment, but on the network side, the network which is evolved, which supports 5G, recognizes that this is a CAT-M or NB-IoT device and allocates to it the bandwidth in the spectrum this device is using. So it actually includes this, let's say, older technology device in the new technology spectrum. What is industrial IoT for mission critical control? There are more areas like private 5G networks, spectrum sharing, URLLC, time-sensitive networks, and positioning. I will only cover some of them, which I think are more important for now. So private networks have some key benefits over existing technology. They're optimized, tailored for the industrial applications, like they have better latency, better quality of service over normal general conditions. They are dedicated. It's a local network, which is easy to deploy, and it's managed independently. And it's secure, so it has cellular-grade security based on SIM card security, what we have now in cellular technology, but keeps all the data, all the sensitive data locally. This is how a private network architecture looks like. So this is still LTE, not 5G. So this is also possible now in current technology. 5G only enhances it. So this means this is not a network. Local network has ENB nodes. This is so-called BTS, what we call them in 2G networks, which are local and communicate through a gateway with the cloud services. So some traffic stays inside. The next one, ultra reliable low latency communication, means that one standard millisecond sum frame from LTE can support at higher frequencies, even denser data structure, so it can transmit more signals in the same time frame. So this is how you achieve lower latency from a shorter slot with higher subcarrier spacing, fast processing with data and control signals in the same slot, as you can see in the bottom side, and also mini slots allowing download and upload data in the same slot. This architecture is flexible and allows fast switching between download and upload, and also using such information to avoid retransmission of the signal. What this comp means, it means coordinated multi-point which creates spatial diversity with redundant communication paths. Basically, knows where each device is more located and generates and directs traffic in that area, in that location. For positioning, the new releases, which are related to 5G, bring more enhancement to current positioning technology. So improving accuracy to 3 meters indoor and 5 meter outdoors. Multi-cell positioning, so calculating round trip time or angle of arrival and departure for timed inference of arrival. For example, this TDOA, time inference of arrival, is already used in release 14 for NB-IoT or Quectel devices. For single cell positioning based on information provided from the cell to the device. In release 17, the scope is to achieve even higher accuracies, like down to 20 centimeters, lower latency, as low as 10 millimeters, and high capacity. So one antenna could support simultaneously more devices and to complement existing technologies. The CV2X technology exists now, so current technology supports this type of scenarios. It's used for direct safety communications, independent of the cell network, so the devices communicate between each other without the need of cellular network. It has low latency, uses direct PC5 interface. For example, provides speed, location, local information like accidents, stuff like this. And network communications are used to complement services. So vehicle to network operates in a mobile operator's landscape spectrum. For example, when you want to extend the reach of the signal, which is not possible from vehicle to vehicle, they use the cell network to indicate, for example, an accident which is ahead to the vehicles behind. The new 5G technology complements release 14 related to CV2X with automotive safety, like do not pass warning or intersection movement assist at a blind intersection, which means you don't have visibility, but there is some user with a mobile phone. Then the network signal, which signals the driver not to pass because there's somebody approaching, but okay, take care. And the release 16 enhances more features like autonomous driving, like local high definition maps, intention trajectory sharing, and sensor sharing. So all the data from the vehicle is passed to the network. So autonomous driving can be done more safely and with more information. As an overview, those are applications and services that are planned to be released in each such release. So release 15, it's the foundation of 5G technology. Release 16 expands the new use cases and industry. So here we have in the middle the 5G massive IoT, which includes current LTE IoT and in the in-band 5G new radio. In the future, for release 17, it's there is continued enhancement and expansion for 5G only services. I will introduce you quickly to our modules portfolio. So this is only a portfolio for LTE Advanced Pro, and 5G from bottom to top.
Radu, can I jump here in
Sure.
Quickly introduce the roadmap by myself? Just for your information, I'm Thomas Rehar, responsible for sales in Southeast region. So everything related to sales actually is I'm responsible, and that's why I would like to introduce Quectel part of 5G, and these are modules. Radu now very good went through technology of 5G, and now actually we come to Quectel, and I selected this slide because it shows very good connection from module side between 4G or LTE and 5G modules. LTE is actually split into LTE modules. This means from 1 to 4 category. Then Cat 6 is LTE-A or LTE Advanced. Then LTE Advanced Pro means modules with category 12 to 20. And then actually 5G modules are starting. We have sub-gig and sub-gig plus millimeter wave modules. In general, modules are split between standalone modules and modules with mini PCI or M.2 interface. Why I show you this slide? Because first thing what I want to show that mini PCI interface or standard, industrial standard, is ending at LTE Cat 6. That's mean routers or devices which have only this interface. In such devices, you will not be able to plug mini PCI 5G module, because simply it does not exist, because simply it's not a standard. So I would suggest for every new design of such device where you are putting interface to put M.2 slot, because this slot continue also in 5G on 5G modules. And to be honest, this is very wise, smart to do it, because you can on one side call your device 5G ready. Yeah, of course, antennas will not cover 6 gig or microwave, so you need to change antennas, but at least your device in theory you can plug 5G modules. But on the other side, if you are doing devices with where you are soldering module, of course there are two by Quectel there are two form factors, and this second form factor is actually pin compatible also with LTE LTE Cat12 model. That's more or less everything from the slide which I want to show you. On 5G, as we said, we have set of modules. Maybe here Radu can say in details what are differences with these models.
Okay, so firstly, they are split into sub-gigahertz modules that support only up to 6 gigahertz frequencies, and also modules that support millimeter wave. You see that sub 6 gigahertz has only 4 antenna connections. One of this is for GNSS, so only 3 for LTE. While millimeter wave have much more antennas. All of these are M.2 form factor because this form factor supports high speed with over USB 3.0 or PCIe interfaces. In the next slide, I have more detailed info. So for the RG 500, we have 2 versions. One is for Europe and one is for North America. Actually, it's Europe and rest of the world, and North America, which have different requirements and different bands. All you can see here with N are bands for 5G, and B are the bands for LTE. You can see here they can support both LTE and 5G. All of them have embedded GNSS, support PCIe 3.0 interface and USB 3.1.0 interface for high-speed data transfer, or RGMI, so Ethernet. The next version, so 502, are actually that are RM. The previous was RGs or modules. Those are already in M.2 format, so they're called RM. Basically support similar frequencies, higher category. Previous was Cat 16, this is Cat 18. It's possible also to have built-in eSIM. This means you have reserved space for eSIM, but which one will be used is optional, depends to end user. And RM510, it's a module that supports also millimeter wave. So you can see here frequencies for millimeter wave bands. Category for download is 20, for upload 18. All the other specifications are similar to others. All these devices are based on Qualcomm chipset. Of course, we have also development kits for all of them. So we have development kits for modules. What you see here, RG500Q, so the left top kit. The solderable module is delivered in a small adapter board that fits on the bigger daughter board that supports more type of modules, and also other devices like codecs or other interfaces which can be connected externally to the module. Then we have the RM500 EVB kit, which fits the M.2 variants, and this can be also connected in the servers or desktops that have a PCI interface. Or also we have let's say mini kit with such module that has already embedded antennas. So it's everything you need in a small form factor, like the size of a credit card. and has a USB-C interface.
At Rado
Sure.
here, all these evaluation boards you can get at SOS, who is our official distributor. So please contact them for modules and evaluation boards. What I would like to add that for now, still for documentation of 5G modules, we still need to ask you to sign NDA for the moment, because this is new technology. So you can buy without NDA demo board, but for the documentation, we need to process this NDA. And maybe here I would like to point out, Radu shows in previous slides that antenna is really crucial component in 5G. And from that reason, Quectel prepared also some standard 5G antennas sets or kits or box. And also these antennas for 5G you can get at SOS. So this is our standard 5G antenna kit, which you can get at SOS. Okay. I believe from our side we finished. Maybe Radu, you can add something.
This is the last slide.
Yeah. So thank you very much for listening our presentation. And as I said, all informations you can get from SOS.